Okay, so there's a corollary to that dot product that that formula for the dot product we just saw, that's u dot v is equal to the magnitude of u, the magnitude of v times each other, times the cosine of the angle between them, right? And the corollary to this is that we have this statement. U as a vector, the vectors u and v are perpendicular, and v are perpendicular to each other if and only if u dot v equals 0. And that is so essential and so nice that it comes up again and again in physics and in math in terms of figuring out how do you know when two vectors are perpendicular. It's just a very, very nice tool because calculating the dot product, computing the dot product between two vectors is pretty simple. It's pretty easy. You just multiply the first two components, multiply the second two components, and add them together. So if we can show that, if we can get a dot product that's 0, boom, we know right away that the vectors are going to be perpendicular to each other. So that's a really, really nice corollary. We'll use that in a moment, but I'm first going to do an example utilizing this formula. Example. And that's that we want to find the angle between two vectors. I'm going to give you one vector's components and another vector's components, and we're going to find the angle between them. Example. Suppose u is equal to the vector 1, 2, and v is the vector 3, 1. Determine the angle between u and v. I'll draw a picture first, and then we are going to find the angle using algebra. So here's my plane, and I'm going to draw the vectors 1, 2, and the vector 3, 1. So here's 1 in the x, 2 in the y. So this would be my vector u. And then I need to go 3 in the x and 1 in the y. And here's my vector v. And so our interest is figuring out that angle, trying to determine theta. What is the angle between u and v? Well, that's the angle between u and v. It's in the dot product. That is, if I find the dot product, I divide it by the magnitude of each vector, I can find cosine of the angle. So let's write down what we know, which is that u dotted with v is equal to 1 times 3 plus 2 times 1, which is 3 plus 2, which is equal to 5. So there's the dot product between u and v. It's 5. And we know that this equals the magnitude of u times the magnitude of v times cosine of theta. So we need to find the magnitude of u and the magnitude of v. So what's the magnitude of u? That is going to be the square root of 1 squared plus 2 squared, which is the square root of 5. And what's the magnitude of v? That's the square root of 3 squared plus 1 squared, which is square root of 9 plus 1, which is 10. So there's the magnitude of u and magnitude of v. So we have everything we need in this minus the angle, which is what we're trying to find. So that says that 5 equals root 5, root 10 cosine of the angle between them. Just see if that's showing up. Let's scoot it over. There we go. So we have 5 equals root 5 root 10 times cosine of theta, which is to say 5 divided by root 50 equals cosine of theta. Now there's a little bit of work to do here. We can simplify this as much as we can. Root 50 is equal to 5 root 2 cosine theta. And 5's can cancel, so that's 1 over root 2, which is the same as root 2 over 2 after you rationalize it. And this should jump out at you. I know when cosine is equal to root 2 over 2. If you inverse cosine this, you'll note right away that it's 45 degrees or pi over 4. So it says then that theta equals pi over 4, or a 45-degree angle. 4 or 45 degrees. Either way, you want to do it if you want to do it in radians or in degrees. And that's how you calculate the angle between two vectors. Use the geometric formula for dot product. Determine the dot product by its definition, find each magnitude, solve for theta. Okay, let's do one more example. One more example, and this one will be about the perpendicularity of two vectors. How do you determine if two vectors are perpendicular or not? This one I want to do go back to blue. Find two numbers t such that the vectors t squared 3 and -4, 5 are perpendicular. So now we're trying to determine how do you make two vectors perpendicular? How do you know if they're perpendicular or not? And using that to find a number t to satisfy this. So from our corollary earlier, which is that the dot product of 0 implies the vectors are perpendicular, that says, solution, dot product must be 0. And so we take the dot product. And since it's an AB form, it's very easy to take the dot product. We do t squared times -4. So this is -4 t squared. 3 times 5, that's 15, plus 3 times 5. And the result needs to be 0 for that to be perpendicular. Look at that. That's easy. It's just a simple quadratic that you don't even need to use a quadratic formula to solve. You can just solve it by subtracting 15. And you have -4, divide by -4, divide by -4, and that gives you t squared equals 15/4. So t is equal to plus or minus root 15 over 2. So if t is one of these two numbers, then the vector t squared 3, -4, 5, and -4, 5 will be perpendicular. Done.